Year 4, welcome to your next math skills lesson. We've got 3 activities that we are going to be working on today, and we've got some key vocabulary that are going to help us with those activities, okay? So you are going to need maybe a pen, piece of paper to make some notes on, and it would be great if you've got somebody to talk to in this lesson as well, because we're not just going to be doing maths, we need to be explaining the maths behind it. So the key vocabulary we have is partition, part, whole, thousands, hundreds, tens, ones. Great, so those elements are going to help us with a couple of activities. Then we've got nearest multiple, numeral, Roman, and representation. Great. So when we're actually looking at Roman numerals, numerals is a way that we can represent part of a number or represent that whole number in a different way to which we are usually seeing nowadays. Let's start with our first activity, which is our very familiar part-whole model, really thinking about our knowledge of number and how we can partition it, so that's split it off into smaller parts to see what our part and our whole is represented. And as you can see, some of our part-whole models have been partitioned into even smaller parts. Okay, you're going to help me with this side of the problem, then I'm going to reveal the next side of the problem for you to do on your own. Okay, so let's think out loud as we are working through some of our examples here. Got 8,653. 8,653. 8,653. Nice simple one to get us started. And we can see our 600 has been partitioned into a part of 450. Meaning if we have another 50, that will take us to 500, and we would also need another 100, wouldn't we? From 500 to 600. So we've got 150 to get us to our 600 there. So we've completed this part-whole model. Knowing that in 8,653, there are 8,000s, there are 600s, and there are how many tens? 5 tens, and there are also 3 ones. Thank you very much. Now we will reveal this side of the problem. You need to pause the screen and give yourself some working out time. Off you go. Great, so hopefully as we read this number, 9,943, we can actually see that this slots nicely into its place value columns, 9,943. We then have our partition of 900, which has then been partitioned into 250. So we've got 250, we add the 50 more, which gets us to 300. So once we're at 300, how many more hundreds did we need? We needed 6 more hundreds. A part of 3 and a part of 6 gets us to that whole of 9. Great work if you manage to recognise 650 as the part there. Again, helping me with this side please by thinking out loud. We have 300, 4,000, 26. Is that the order we would like to read numbers? No, we like to go largest first. 4,326. 4,326. Thank you for keeping me right there. Now with our 4,000, we've already got 1,500. We had 500 more, that will get us to 2,000, right? And how many more thousands do we need? If we're 2,000 and we need to get to 4,000, we need 2 more thousands, don't we? For 2,500. Great work if you manage to recognise that. Now we can look at our whole. We've got 4,326. We know that number is made up of 4,000s, 300s, 2 tens, also known as 20, and 6 ones. Great work if you recognise that. You've now got to work on this part-whole model by pausing the screen and giving yourself more working out time. Right, so again, the order of the numbers aren't quite right. We've got 200, 5,550. When we're reading numbers, we would like to start with the largest with it. In this case, is our thousands. But 200 and 500 have a likeness. So we need to combine those together. 500 and 200 gives us 700. So actually, Just cross that out for the moment. We've got 700. We've actually got 5,750. 5,750. Good work. Our 5,000 has been partitioned into 1,300. How many more hundreds do we need to get to our next 1,000? Yep, number 1 to 10 will tell us we need another 700. That gets us to 2,000, and if we're 2,000, we need 3 more thousands to get us to 5,000. So we've got 3,700 there. Great work. Again, thinking out loud, helping me with this part whole model. We have got 90, 10,000 this time. Sometimes you might find a comma just after there to help us partition our thousands away from our hundreds. Then we've got 80 and 1. 90 and 80 are a likeness, so we need to combine those together. So 90 plus 80, 9 tens plus 8 tens, 17 tens, which is also 170. So we'll cancel that out, and we've got a part of 170. Now when we're looking at combining that number, 10,171. 10,171. Fantastic. And we can see our 10,000, we've already got a part of 4,000. So to get us to our 10,000, we need 6,000 more. Hopefully your number 1s to 10 are still being put in use to help us with these larger numbers. So help me out. In 10,171, there are 10,000s, 100, 7 tens, and how many ones? Yes, just the 1, 1. Good work. Now it's up to you to solve this part whole model. Okay, pause the screen, give yourself some more working out time. Fantastic. Again, you can see we're using the 10,000 here. We've got 500 and we've got 1730. What do we notice about 1730? Yes, they are both tens, they are a likeness, so we need to combine those together. And actually 1730, 7 and 3 tens, is actually 10 tens, which is also known as what? Was it 1,000? No, I got happy with my little zeros there. Great work. Yes, it is known as 100. Fantastic. So now we've got 10,500, 100. We've got another likeness of 500 and 100, which combines together as 600. So now we have 10,600. Again, you can put the comma in there, but it does not need to be there to be mathematically correct. We've got 10,000, which has been partitioned into a part of 7,500. Another 500 will get us to the next 1,000, which gets us to 8,000. And to get to 10,000, when we've already got 8,000, we need 2 more thousands. So actually 2,575. 7,500 gets us to 10,000. Just like 25 and 75 would get us to 100. So look at those relationships in there. Right, as you can see, my part whole model is complete. However, the red X on my screen signifies that there is a mistake in this problem. It's your job now to have a little think about the mistake that has been made. So pause the screen and see if you can spot the mistake. Off you go. Great, we're back in. So let's look at what we know so far. Got a large number there of 8,000, 1,004, 350, 120, which supposedly makes the whole 9,464. Let's have a look. 8,000 plus the 1,000 gets us actually to the 9,000. So I can see the 9,000 there, which makes me happy. I can actually see the 4 as well, so we can match up the 4. So now I'm looking to see if we've got 460 in these two parts. The 300 and the 100 combine to be 400, so I can see the 400. However, 50 and 20, that doesn't come to 60, that actually comes to 70. So we've actually got 470 there. So we had the 9,000, we've got the 400, we've got the 4, but actually, for this to be correct, this needs to be the whole of 70 there. 9,474. Unless you could change one of these parts to become 9,464. You could have altered either way. Let's just check this is correct. 8,000, 3,500, 4,500. I know 8,000 is 4,000, 4,000. This number is 500 more, but this is 500 less than that. So I can see that balancing out. 4,500 add the 500 gets us to 5,000, add the 3,000 gets us to 8,000. So fantastic if you manage to recognise the errors there. Same again for you to work out. There's a mistake in here. I need you to spot the mistake and correct it. Pause the screen to give yourself more working out time. Right, great. So we've got the whole of 6,902. Is that correct when these four parts are our parts? We've got 1,450, 5,001, 450 and 1. So 5,000, I can see 5,000, I can see 1,000. 5,000 and 1,000 is our 6,000, so I can see that. What I like about this number is we've got 450 here, and we've also got 450 here. Combine those together, and if you know your double facts, that's our 900, isn't it? Great. Then we've got our 1 and our 1, which combines to get our 2. So looking at these parts, these four parts do actually combine to get that whole. But let's see if these two parts help get this whole as well. So we've got 2,501, then we've got 2,499. If I put that one over, make this 2,500, and also make this 2,500, hopefully our double facts tell us that that would equal 5,000. So actually, the inaccuracy is in either one of these two parts where we needed one more. So you needed to find one more to get to there. Okay, you might have added one more to the one less to the whole and taken one off that, and again you would get the correct answer. So there are many different ways you could have corrected that problem. Now, we've worked and we've practiced. Now it's your turn to do some more practicing. We've got 5 part whole models for you to work out. Pause the screen, give yourself some working out time to finish activity 1. Off you go. Right, we're back in. We can see 6,000, 1,000 to give us 7,000 plus the 500 and the 40. So 7,540 should be your whole there. 6,000 is being partitioned to 2,500. Add 500 gets us to 3,000. So we get another 3,500 there. We now have the whole of 1,188. We can see the 1,000. We can see the 100. The 20 and the 30 actually only gives us 50. And we needed 80, so we needed another 30 there. We've got 4 of the 8, we needed another 4 as well. Yeah, so we've got 34 and 34 gives us 64 plus the 20 gives us, doesn't give 34 plus 34 gives us 68 plus the 20 gives us 88. Good work for correcting. Then we've got 1,000 which is being partitioned into 330. Add the 70, number bonds come in handy there to get you to 400. Then you need 600 more to get to that 1,000. So you need 670 there. Give yourself a nice tick if you manage to solve that part whole model. Here we've got 9,250, 420. I like the look of 420 because if I take that off the 920, I'm left with 500. Yeah, and we've got our 9,000 here, which is great. We just need 500 more, don't we? We need that 500. We've currently got 250, half of 500, so actually if we've got another 250, we'll be able to complete that off. Then our 9,000, we've got 7,001. It would be great if that was 7,000 because we know we just need 2,000 more, but we've got that one more, so we'd actually need one less than 2,000, which is 1,999. Great. Over here, again we've got 250, 250, which gives us 500, which comes in handy. So we've got 7,508. Unfortunately, we don't have any 10s, so a 0 there as our placeholder. With 7,000, we partitioned into 3,200. We would need 800 more to get us to the next 1,000. Gets us to 4,000, and then we need 3 more thousand. So actually, we needed 3,800 there. Again, give yourself a tick if you've got any of these part models correct. And our last one, 7,364. We can see the 7,000. We can see the 300. And we can see 1, 2, 3. So we can see 3 of the 4. So we're missing 1 to get us the other part. And we're also missing the 60, aren't we? So we're actually missing 61. Our 300, we've got 99. 1 more will get us to 100. Then we actually need 200 more. So we actually need 201 to get us there. Hopefully you managed to solve that. And remember, there are more ways to be as efficient as possible, so do consider those. We are on to activity 2, which is a familiar activity if you've been joining me with these videos, where we are going to be looking at rounding to the nearest multiple. To round to the nearest multiple, you need to be good at counting in those multiples. So at times we might be counting in tens, multiples of 10, we might count in multiples of 100, and sometimes we might count in a multiple of 1,000. Great. So, to start us off, we need to find out which multiple of 10 we are currently at. Okay, so this number, 674, means the multiple of 10 that we are currently at is 670, yes. So we're currently at 670. So we've gone from 660, 670, meaning our next multiple of 10 is going to be 680. Fantastic. We know our midpoint is going to be a 5, isn't it? So in the middle of our number line, we have the number 5. So we're at 675 is our midpoint. Any number that lies on the line before it, we round down. Any number that lies on it or above, or further along, should we say, we need to round up. The 4 tells us we are before 675, meaning we need to round down. Great. So I'm rounding 674 to the nearest multiple of 10. We round down to 670. Great. Find the multiple we're currently at, find the next multiple, look at that midpoint and see what the digit to the right tells you need to do. Okay? Your turn to work through this problem where you are rounded to the nearest multiple of 10. Pause the screen, give yourself some working out time. Great, so which current multiple of 10 are we at? We are currently at 630, fantastic. Next multiple of 10 would be 620, 630, 640, fantastic. Our midline would be 635, but this number is actually only 631. So we know it's quite early on our number line, meaning that we need to round down to 630. Great work. Now, we are still rounded to the nearest multiple of 10. Great work that you're checking that. We are currently at 650. Our next multiple 10 will be 660. Great work. Our midpoint will be 655. Fantastic. But we're currently at 656, which is, yes, just after the 655 there, which means we need to round up to 660. So I'm rounding 656 to the nearest multiple of 10. We round up to 660. Now it is your turn. Again, round to the nearest multiple of 10. Consider where we currently are, consider the next multiple of 10 and see whether you need to round up or down, looking in that ones column. Off you go. Great. So which current multiple of 10 are we at? We're actually at 700, aren't we? We've got no multiple of 10 there. The next multiple of 10, 690, 700, 710. Fantastic. So actually in that midpoint, we'd have 705. Fantastic. But if we look at our number, we're not currently at 705, we're actually only at 704, which is just before our halfway point, meaning we needed to round down to 700. So great work if you managed to recognise that. Now, we're rounding to the nearest multiple of 100. We are currently at 4,400. So we're currently at 4,400. So before that we would have 4,200, 4,300, 4,400, 4,500. And the midpoint would be between 400 and 500 is 4,450. But we're not at 50. This number is actually only 30. So if it's only 30, we know that it's positioned before 50 in the number line, so meaning we would need to round down to this multiple of 100. So when rounding 4,430 to the nearest multiple of 100, we round down, yeah, we do. We round down to 4,400. Great work. Your turn now. Round to the nearest multiple of 100, see where we're at, see the next multiple, and check the digit to the right to see where you need to round. Off you go. Pause the screen to give you more time. Right, to your nearest multiple of 100, we are currently at 1,300. We're currently 1,300. The next multiple of 100 would be 1,400. Our midpoint between 300 and 400 will be 1,350. Are we at 50 quite? With there only being two tens, we're not. We're actually before it on our number line, meaning you needed to round down to 1,300. An activity you are certainly getting much better at. Right, now we're rounding to the nearest multiple of 1,000. This time, which 1,000 are we currently at? In 6,926. We are currently at 6,000. Our next multiple of 1,000 will be 7,000. Our midpoint between 6,000 and 7,000 will be 6,500. But we can see in our hundreds column there, we're actually at 900, which is very close to 7,000. Lovely. So that means when we're rounding 6,926 to the nearest multiple of 1,000, we round up to 7,000. Good spot from you. Now down. This is your turn. Pause the screen, give yourself some more work now time. Right, so we've got nearest multiple of 100 here. So great work if you managed to spot that. Which 100 are we currently at? We're currently at 8,400. If you were tricked by that, pause the screen and make sure you are rounding to the nearest multiple of 100 and not 1,000. So 8,400. The next multiple of 100 would be 8,500. Our midpoint between 400 and 500 would be 450. We know that's in the middle, but we're currently only at 3 tens, which is 30, and we know that that is before. So you needed to round down to 8,400. Now, you've got a grid where you need to round all three numbers to the nearest multiple of 10, nearest multiple of 100, and nearest multiple of 1,000. Okay? Nearest multiple of 10, 100 and 1,000. Pause the screen, off you go. Great work. So I'm going to reveal the answers. Let's work them out together. We've got nearest multiple of 10. we either have 1,230 or 1,240. The 7 tells us we are closest to 40. Nearest multiple of 100, we're currently at 1,200. The 30 tells us we are certainly closer to 1,200 and not 1,300. Round to the nearest multiple of 1,000, we're currently at 1,000. The next multiple would be 2,000, but the 200 tells us we are closest to 1,000. So give yourself a nice tick if you manage to solve those. 4,507, closest 10, multiple of 10, would be either 4,500 or 4,510, and we're actually closest to 4,510 because we're at that 7. Multiple of 100, we're currently at 4,500, the next one would be 600, but we've only got 7 there, we've actually got no 10, so we are certainly a lot closer to 4,500. With multiple of 1,000, we're currently at 4,000, the next multiple would be 5,000, and we're actually at that midpoint, just over the midpoint with 500, so actually we need to round up to 5,000. Then we've got 9,049, nearest multiple of 10, are we closest to 40 or 50? With being 49, we're no way closer to 50. Multiple of 100, 9,000 or 9,100. With us being at 49, we're actually closer to 9,000. We're just before that midpoint, aren't we? And then with our multiple of 1,000, again 9,000 or 10,000, but we've got 0 hundred, so we know we are way closer to 9,000. So again, give yourself a tick if you manage to solve those correctly. Go back and check if you've made any errors to correct them. Really good work. Our third activity today is Roman numerals. So before I get started, I want you to pause the screen and I want you to see if you can finish my key for me. So these are different representations of numbers and I need you to complete this key for me before we get started. Off you go. Great, so hopefully we've got a complete key where the I represents a 1, the B represents a 5, the X represents 10, the L represents 50, the C represents 100, the D represents 500, and the M represents 1,000. So that's hopefully your complete key, which you might find helpful when we have to work through these examples, because we're going to transfer this number into a representation of Roman numeral. So if we've got 31, we have 3 10s and 1 1. So put our 3 10s, XXX, XXX, and the 1 is just an I. We've got XXX, I is our 31. I want you to work on this example by pausing the screen and giving yourself some work now. Time, off you go. Great, so we've got 65. Do we do 6 10s? No, we've got a 50 there and a 10. So 60 can be made up of 50 and 10. So we've got L for our 50 and X for our 10. Then we've got our 5, which have the representation of V. So we've got L, X, V. Now, 90. Thinking about the rule, Roman numerals don't show 3 in, or more than 3 in order. So think about how we could represent 90. Off you go. So 90. Yes, we don't go with 50 and 4 10s. We actually go with 10 less than 100. So we know 100 is C and 10 is X. So if we put the X before the C, this means 10 less than 100. So well done if you managed to represent that. Your final example for this slide is 150. Please can you represent that using Roman numerals? Pause the screen, off you go. Quite a simple one when you look at your key. Got 100 being C and 50 being L. So actually it's just a C and an L together. So not quite a complex one there. Off you go again. Pause the screen, complete the key, and use that key to help you with this example. So do the key first, and then we can refer through it throughout. Off you go. Right, so our key should have 1, 5, 10, 50, 100, 500, and 1000. Great way to make sure you don't make any errors is making note of the knowledge that you know. 74 can be partitioned into 50 and 20. So we want our L from our 50, and we want two 10s to get us our 20. The 4, again, remember, we don't show more than 3 of the same numeral together in Roman numerals. So with we need in 4, we go 1 less than 5. So we've got 1 less than 5, and together that represents 4. It's fantastic if you remember that bit of knowledge there. A really relevant one for us now, 2020, the year in which we are at. Think about it. How many thousands are there? How many tens are there? How can we represent it in a Roman numeral? Off you go. Pause the screen to give yourself working out time. So lovely, we actually have 2 thousands there. So we have an M and an M. And we have 2 tens there in 20. So we actually have an X and an X. So XX is actually 2020. A really relevant one for us now. 604, again, use the key. Pause the screen, give yourself some working out time. Off you go. Right, 600 is actually made up of 500 and 100. So if we use the 500 for the D, the 100 with the C, and the 4, remembering 4 from before, 1 before 5, which is 4. And finally, your last representation that I would like you to do is 752. Can you represent that as a Roman numeral? Pause the screen, give yourself some working out time. Right, so 700 is made up of 500 and 200s. So we've got a D for the 500. The 2 of the hundreds get our 2 C's there. Then we've got 52. 50 we know has its own letter, which is L, and the 2 is just 2 ones, which we can represent with our I. So fantastic there. Now, year 4. A little bit of a game now. Because with Roman numerals, there are certain rules with the knowledge that we need to know. I have created a true or false game where I've shown 3 different ways that somebody might represent 39. You need to tell us which one is true, which one is false. See if you can spot the common misconceptions. Off you go, pause the screen, give yourself some thinking time. Right, we're back in. So as you can see, we have 3 x's, which we know is 30, plus the 5, which is 35, and then we've got 4 ones. But remember that knowledge rule in Roman numerals, we don't see 4 of the same together. So actually, that is not a true representation. Here, we have XXXX, which is 4 x's, which is 40. And then we've got the 1 before the 10, which is 9. So we've actually got 49 there. Is that what we needed? Nope, not today. And then we have 3 x's, which is 3 10s, which is 30, plus the 1 before 10, which is 9, which is 39. So this is our true representation of that numeral. Now, a different one. Pause the screen, look at 112, refer back to your key if that helps, but see which one is the true representation. Off you go. Pause the screen to give yourself more work now time. Right, let's have a look. We've got 100, 10, 10, which is actually 120. Not quite what we wanted. 100, 10, 2, which is actually 100, 110, 2 ones. 112. And then we had L and X. L and X is, yeah, that's 60. Plus the 2 equals 62. Great. So, which one was true? This one in the middle here was true. CXII. CXII, 112. Now, the ball is in your court. Got the number there, 98. I would like you to represent it in 3 different ways, 1 of which is accurate and 2 that are inaccurate with a common misconception that might happen. Okay, think about those mistakes to try and trip someone up. Off you go. Fantastic. So hopefully we can look at 98 being 10 before 100 gives us our 90, and then our 8 being our V, I. That will be our true representation of 98. You might trip someone up by going 2 before 100, but we know it doesn't work like that. So that would be 98. And some people might actually go L. So we've got our 90 there, then go for our 8. So there are lots of ways that we can trip up with Roman numerals. So this will be our true representation. And that is us for today, year 4. Well done, you've worked way through 3 different activities, not just doing maths but also explaining maths as well. Well done, keep up practicing at home. Thank you.